if it works. Okay, so as you know, we have 30 minutes for 3 presentations of about 10 minutes each. So please leave some time for question and discussions. And you should know that it's also recorded, which I think I haven't started recording, but I'll do it for sure as soon as I finish with this.
I actually started recording already.
Oh, thank you. I appreciate it. And we will be posted on YouTube. So if you have colleagues or friends that are interested also by this topic and could not attend. And today we have 3 presentations, one by Takuya from IBM, and 2 presentations by Adam, which will be somewhat merged together. And to be aware, the next roadmap discussion is on September 17 and European friendly time of 10 a.m. PST. All right. So let me now ask Takuya to present, and you can start with your topic. And thank you.
Let me share my screen.
We can see it.
Okay, hello everyone. I'm Takuya Nakaike from IBM Research. So today, let me briefly introduce our proposal about the new machine learning pipeline framework with the new Onyx operators. So this is a summary of our proposal. So that the motivation of this proposal comes from some findings in Kaggle use cases. So as you know, so Pandas data frame is very popular and frequently used to write the data preprocessing code in Kaggle use cases. But I found that most of them do not use the pipeline, existing pipeline framework. I thought that that is because there is no full functionality in existing pipeline framework to represent a typical pattern of data preprocessing. Especially, I found that current pipeline framework cannot represent the new feature calculation from the multiple features. And also, so the Onyx lacks a few operators to represent typical patterns of data processing. So we prototyped the new pipeline framework called the data frame pipeline on Python, which convert the typical data preprocessing patterns on Pandas data frame into Onyx format. And at this prototype, we prototyped 3 new Onyx operators. One of them is date operator, which parses a date string to extract a time feature such as a year or a month or a week and so on. And also we prototyped 2 simple operators, StringConcatenator, which concatenate multiple strings, and a StringSplitter, split a string based on a given separator or index. Next slide shows the overview of our pipeline, machine learning pipeline framework called the data frame pipeline. So this framework is already open sourced on the GitHub. So if you are interested in, please look at it. And in this framework, so you can define the machine learning pipeline by using our live API, data frame pipeline. And you can define the pre-processing steps like this. So in this step, so you need to use our provided API such as StringConcatenator transformer and the label encoder and the column selector and so on. And each transformer, you need to specify the columns, input columns and output columns and so on. So, and this framework runs on the Python when at the training phase like this. So I mean that this pipeline framework works on the Python for the training, and after that the model such as the XGBoost model is trained by using the data which is an output of our data frame pipeline. And our framework can consume the already converted Onyx machine learning model and the pipe model, and output export the Onyx file, which includes the preprocessing operator and the model operators. And as you already know, so this Onyx format can be consumed by some Onyx runtime, such as Onyx runtime provided from Microsoft. So this is our framework. And in this prototype, we implemented the 11 data frame transformer on Python and mapped to the Onyx operators. So the most of the operators are simple mapping, such as label encoder or scalar and so on, one-hot encoder and so on. But some tricks are needed, such as the function transformer, which takes a lambda function, and our framework analyzes the lambda function and converts it into the arithmetic operator, such as add operator or mean operator, multiply operator, and so on. And another difficulty is that aggregated operation, such as the frequency encoder and aggregated operator. So this operator takes one or two columns, and that some values obtained at the training phase is used at the test prediction inference phase. So this example how we convert the frequency encoder into the Onyx operator, label encoder. So that this operator counts the frequency of values in a column. And we create the mapping table like this. So that in this case, so the A appears 3 times. So the A is mapped to 3, and the B appears 2 times. So B maps is mapped to the 2. So the generating this kind of the dictionary on Python, we converted this mapping data to the label, embed this mapping data to the label encoder like this. So in other words, so our approach is does not perform the aggregation operator on the Onyx. Instead, we generate the Onyx operator with the cached value like this. And also the last three operators are new operators which we prototyped. So StringConcatenator and StringSplitter and data transformer. This is the final slide. So that this is the preliminary experimental result by for the performance when we convert the data frame pipeline from the Python to the Onyx. So this is the speed up to the Python implementation. And the yellow bar is the performance when we run all of the data preprocessing and the machine learning model on Onyx. So the blue bar is the performance when we run only the preprocessing on Onyx. So the machine learning model is run on Python. And gray bar, you cannot visible, but this pattern is that the preprocessing is running on Python and the machine learning model is running on the Onyx. So as you can see that when we run the preprocessing on Onyx, we were able to get a great speed up, such as 300 times performance improvement for categorical encoding and so on. And also we compare the prediction accuracy like this, and there is was no much difference between the original code and the accuracy on our data frame pipeline using Onyx like this. So this is our proposal. So any questions or comments so far?
The set of operators that you showed in the table in the previous slide, is that the data frame transformers? Is that the complete list of transformers that we would need, or is this only based on some models that you looked at?
Currently, so we introduced only the 3 new Onyx operators. So these are the already implemented our data frame pipeline framework. And the upper 8 transformers can be mapped to the existing Onyx operators. The last 3 are needed to introduce introduce of new Onyx operators. Yeah, this is
maybe another way to phrase this question is like, if we have all of those operators, both the black one and the red ones, how much coverage do we get in the Kaggle benchmarks? Do we get all of them or a fraction?
Yes. In the current benchmark, these operators all of the pre-processing. Yeah.
Do you have a notion of how much of the date usage it's going to cover? Right. So do pandas support some subset of all dates? Is it only going to work on like the Gregorian calendar dates from like Common Era, or is it? Do you need to be able to support different calendars? Do you plan to do that?
At this time, so that we did not use the other calendar, so that we I don't remember in detail, but I used the existing C date parser library, so that the implementation is not so tricky, I think.
But so are you just doing dates? Do you pass times as well? And if you pass times, how are you going to cope with time zone updates and that kind of? There's an awful lot of complexity to date processing once you get past a certain
Yeah. Maybe it may need some such functionality, but at this time, so that we did not pass any time zone data, so that it is used. I think. We need to. Yeah, I remember it. So that we need to pass some base time to calculate the year or month or and so on. Yeah, you are correct.
So it sounds like this is some work that would be needed to be done while doing the formal proposal of the date to make sure that it covers many of the users that the community needs.
Yeah.
Is there one more question from the community? All right. So then let's go to the second presenter, Adam. The floor is yours. Thank you very much for this presentation.
Thank you.
Okay. I'll be able to. Oh, looks like I will be able to. Sorry, Zoom was being temporarily grumpy. So I do not have so much detail as the previous presenter. I just have a couple of relatively quick suggestions. So I'm Adam Pocock. I'm in the Machine Learning Research Group in Oracle Labs. And we've sort of been working with Onyx more recently from Java, as you might expect, at Oracle. And this is just sort of some suggestions I have based on the difficulties we've had working with Onyx, emitting Onyx things and interacting with them on the Java platform rather than sort of based in Python. So the first one that I sort of checked was, so the Onyx core project has a lot of functionality in there, like the Onyx project, and like there's the optimizer package and various other bits have lots of C++ code, which just has Python endpoints, right? It's all wrapped in Python, and it's not clear if the C++ is a valid target for binding, right? There's lots of things in the Onyx project, and all of them are very useful. I'm focusing on the utilities because they're the bit I need, I want to care about at the moment. But as Onyx sort of spreads out, and it does appear to be spreading out across the ML ecosystem, we're going to need to interact with it in other languages than Python. And so principally, like, we would like the model checker to be visible in languages that are not Python, so that I don't have to shell call out to Python as part of my unit tests, or when I'm developing something, I don't have to ensure there's a valid Python environment in my system, or when I'm trying to deploy it. We had a use case with Onyx Runtime, which Prasant might know about, where the model checker would reject models, but ORT would occasionally segfault when it consumed them due to various issues in the way it was parsing them. But the model checker was something we could have used to validate that if we could have easily got into it but we couldn't because we'd have had to have a Python VM installed where we had the Java system running, and it would have been very complicated. So this model checking functionality seems to me to be core functionality that would be very useful to be able to expose across other languages. Also, there's some things about modifying operations like upgrading between offsets. Some of those are offline operations you might be okay to have Python with, but the model checking seems very useful. And whilst I would like to get it in Java, I do not expect everyone to write a Java API, right? That's too much. But a C API is something that most languages can easily bind to without a lot of user code. So Java has an automatic, or is getting an automatic system for binding to C APIs and running with them. There's things like Swig and lots of other languages have sort of FFIs that let you automatically bind to libraries if you have a C header. They don't necessarily cope as well with C++ APIs for various reasons. And also it's not clear if the C++ API of any of these tools is considered to be an appropriate target for binding, which I think is part of the real problem that I sort of have with this. Is part of the real thing that's the ask is just figuring out what is a stable API and what is an appropriate thing for people to bind to. So the library that our group creates called Tribio is a Java ML library. We're adding Onyx export support, but at the moment we have to use Onyx runtime via its Java API to validate that we exported the models correctly, because we don't have anything else that we can call into that's within the Java ecosystem that doesn't require us to spin up a Python VM, which is sort of tricky to do in our test environment. I think the situation is similar for ML.NET. I don't think they have access to the checker. I am not as familiar with ML.NET as some of the people on this call will be, so I don't want to speak for them too much. But in general, like, I don't think it's that easy to get hold of this functionality from other platforms. And as I said, C APIs are better at interop than C++ APIs, and you can automatically bind them. If that's right, writing that will require some effort and some design effort and some thought and construction and maintenance burden, right? Which might be too much. If that is too much, then is it possible to sort of denote which of the C++ APIs would be stable entry points, would be things that we can easily access and we're okay to bind from other languages because they're not going to change out from under us? So this is particularly a point because it's very common to bind C++ APIs in Python using pywrap or pybind or something. So for example, TensorFlow does this and Onyx Runtime does this, and they get extra functionality because they bind directly to the API and get access to all the C++ internals rather than going through a single header file that performs a sort of a barrier that is the coded to interface. So it's sort of a question of defining what is the useful coded to interface. Is it just like the whole thing and there's no subdivision between Python and C++? It would be useful if there was a subdivision. It would be even more useful if that subdivision was via a C API that everybody else could use as well. But you know, each of these have different development costs and may well not be of interest to the community. So that's all really I have to say about this specific point. I have another slide which is about sort of dealing with Onyx from other languages than Python as well. I can roll directly into that, or we can take questions about this bit specifically if people are interested.
I don't want to speak for IBM, but I know that Java is also a very interesting interface for us. So I think you're definitely not the only one. My other question is, like, would you be willing to contribute to some of this effort?
I'm already maintaining 3 Java open source machine learning projects. So I would be happy to participate. I don't think I could write the whole thing myself. And to some extent, I am a Java programmer and I can write some C. I am not a C++ programmer and I'm especially not familiar with modern C++. So there's some aspects to that where I don't really have the background and do not have the time to get up to speed on that background. So
I didn't mean you
to participate.
That's wonderful. I mean, that's a good start. I didn't mean you personally. It could be also somebody in Oracle.
Yes.
So
like so I can talk to wider people in the company and see if people are interested. Right. Like, it doesn't seem worth trying to galvanize a large effort unless there's any interest, and we didn't want to try and fork anything because that's not what benefits them. Seems like there are no other questions. Shall I move to the next topic? No. Okay. I had the focus wrong. There we go. So this is about exporting Onyx models and emitting them from other languages than Python. So ML.NET, and so I talk about ML.NET a little bit here. I have not been in direct contact with the developers on this topic. I've just looked through their code. So yeah, I do not wish to speak for Microsoft. Anyone can correct me. But ML.NET and Tribio library are two projects which I know of that export Onyx models from languages that are other than Python. So C# in the case of ML.NET and Java in the case of Tribio. Both of them have a pile of Onyx related helper functions. You can see Microsoft's package for it there, and you can see our package underneath. Our package in particular is currently under active development and is expanding to cover the set of models that we support. We're in the process of doing this. It's just the way the roadmap overlapped with our development cycle. And all this functionality, or much of this functionality, as far as I can tell, is also in this Onyx Converter Common project used in Onyx ML tools and a few other places. That means that there's 3 different implementations of basically identical functionality. I'm not clear on exactly what the ownership on them are rooted under the Onyx project. Our Java one, as I said, is still very much under construction. But it seems relatively wasteful to have 3 projects that all let you interact with Onyx models and generate them appropriately and try and ensure that their invariants are verified so that you produce nodes with the appropriate attributes and you don't construct malformed graphs. As I said, I would like the model checker to validate that I'm not producing malformed graphs, but we would also like our code to prevent us from producing malformed graphs by ensuring that those are type errors or other kinds of errors. So it seems very strange to me that there are 3 different implementations, none of which share any code. And so each one of them could have bugs in how it exports Onyx models. When we fix any one of those bugs, nobody else benefits apart from the project that depends upon that. And that seems to be a waste of effort, in my opinion. Admittedly, the Python one, I think, is far and away the most used one. So that needs the most development effort. It's probably got the fewest bugs. Our one is still under development. I'm not clear on exactly the status of ML.NET's one. But as a lot of this stuff, like the Onyx Converter Common project has a bunch of things in C that uses, uses a bunch of things from the Onyx project, the main one. If we had a sort of common API that everyone was willing to use that we could bind in C, then we could all use that same API. That API could end up being part of the spec. It's the approved way of generating nodes and graphs, and that means there's only one place to validate them. There's only one place to ensure that everything is up to date, and there's only one piece of code that you have to update when you add new ops, or when you modify an op and change its attributes, or the other things that happen as the evolution of the spec. That seems like it would be beneficial. There would be work definitely in migrating all of the different use cases on top of this common API, but then we'd all be working on a common API, which would hopefully let us share some strength across that and make it easier. And it would make other projects which are trying to write Onyx models outside of Java or C# or even outside of ML.NET or Tribio, right? Our package is certainly reasonably tightly bound into how Tribio views the world. ML.NET is also relatively tightly bound to how ML.NET views the world. And the Onyx Converter one is kind of bound into how scikit-learn views the world, at least a little bit. So it might be better to have an implementation that we could share across all of them, and then other machine learning libraries in other platforms or other packages with other paradigms have a common language with which to emit Onyx models. You can definitely do it by writing the protobus by hand. It's not very pleasant to do so. And it's also difficult to validate that your work is correct if you are taking that approach. So I think that it would be generally of use if there was some shared effort on that. Again, this is a lot of work to do these kind of things, right? You'd have to sit the different projects on top of it. And I'm not saying it's a short-term effort or anything, but if we want to grow the Onyx ecosystem beyond Python, it seems like this might be of interest.
Hey, Adam, from what you said, am I hearing right that you think Onyx Converter Common might have the core set of functionality that you'd want?
I think it probably does. I am not especially familiar with it. I only sort of hit it every so often. So as part of the work we're doing to add Onyx export functionality, I'm basically looking at how Onyx models are exported via Onyx ML tools or ML.NET, because the documentation in the Onyx project is not quite specific enough really for me to quite understand how it's used. Particularly, I've been looking at the decision tree stuff recently, and that's I feel like that could probably do with some wording clarifications, because I really had to go and look at the Python code to try and figure out what exactly it was doing and how everything was bound together. Possibly because decision trees are such an alien concept to the sort of tensor-based view of the world that Onyx generally has. But I think that a lot of that functionality does exist in there. Certainly, so one core thing that happens in all three of these libraries is there is some notion of a scoping that can generate you fresh names of a particular attribute type or a particular subtype to ensure that the namespaces are all kept separate and the names are all unique. We all need that because Onyx requires the names are unique. And there's sort of topology stuff in there about managing different graphs. If you're patching graphs together, that's something that, again, we all need. Like if you do, especially if you're dealing with ensemble models, especially arbitrary ensemble models, where you just have a vote on top of a variety of different classifiers. So I think that a lot of it is there. It's just getting it exposed in the right way to other places, and so it's easily consumable from other projects. I mean, you know, the ML.NET is going to have its converter. In Tribio, we're still going to have our Java Onyx converter, because any effort here will take longer than our release cycle for when we want to have Onyx support. But I think if we all start to work together, it might be beneficial.
Yeah, looking at Onyx Converter Common, it looks like the code is all in Python, actually.
Yeah, but so I misspoke earlier. There's some of the stuff that it uses from Onyx, which is C and has some sort of wrappers around the protobuf generation. There's also a helpers.py in the Onyx project, which is sort of aids with the generation of the protobufs, but is actually relatively in common with the other things in the other languages. And then there's the Onyx Converter Common, which has a sort of Python-y view of it. But all three of these packages have something that does scoping, something that does naming, something that allows you to patch graphs together, because that's functionality you need when writing Onyx models.
Okay, makes sense.
Is there a sense of which SIG it would fall under? It feels like it's falling under several. Or...
If we want it to be kind of a common tool that is used by different folks, I think it's probably under the architecture infrastructure SIG, just like, you know, the model checker and some of the other kind of commonly used tools.
Thank you.
Any other questions? That's all I had.
So I don't have. I know there are folks that do Java and are interested in that. So they're not here on the call, I believe, but maybe I can put them in touch with you if
I'd be very interested.
Okay, so that's about the time we had. So thank you so much for the presentation. That was really very interesting. You kept to the time, which is fantastic. If you can send me the presentations, I suspect we need to put them somewhere, if that's okay with you. And the recording will be also saved and put on YouTube.
Sure.
Thank you so much. And we'll see you again on September 17 at the European Friendly Time of 10 a.m. PST. Thank you.
Thank you.
Bye now.